Okay, so before we move on to the theory of the periodic trends for the atomic radii, just to briefly cover the experimental evidence. So it is determined experimentally. We use X-ray diffraction, and then the mathematicians work out the distances between the atoms. This is a separate technique over here where they reflect light of an instrument that goes over the surface of the atoms, and they can see them in a sense as well. Okay, so that's the experimental behind it, the experimental evidence. Now, what's important later in some analysis of questions, etc., just be aware that the nucleus is pretty much just nothing. It's just a speck. And so within the plus or minus of a factor of 10, the elements, the difference between the electrons and the nucleus is the size of the Earth if it's the shell, and the center would just be a little tennis ball. So that's a few thousand kilometers or whatever. So the huge distances in the atoms, mainly space. All right. And then Coulomb's law is highly important to understanding a lot of this. So that distance is the r squared, the radius, and it's squared. So if you double the distance, you are making the force 1/4 less, not half. And so you can do experiments with the balloons. Chart it up the same each time, number of rubs on your head or whatever, and then use a distance of ruler there, and you'll see there's an exponential difference in force. So you can experimentally prove that in the lab. So that one's extremely important. That distance is more important than the size of the number of protons, the force of the nucleus, because that will help us understand the trends. Okay. It's also important to give the key terms. So these terms are the ones that are going to be needed. So the first one is nuclear charge. So how many protons are in the nucleus, how positive it is. The second one is the shells here. So valence electron shell, or you can use outer principal energy level, which is the more IB speak. And so they are the shells on the outside. Okay, so there are other energy levels or electron shells, but we will focus a lot on the valence one, or the outer one, the outer principal energy level. And what happens due to the inner ones is called electron shielding. And so these electrons are blocking the attraction of the valence electrons to the positive nucleus. They're also repelling as well. Okay, so I think we're ready to move on to the first trend, which is atomic radii. Now, because we're going to go into a deep dive and talk about a lot of things, I think students get very confused about what's the important thing. So I've just started with an overview first. So if you're in trouble, just think these overviews first, the main point. Okay, so the main point is for group trends going down, they get larger because they're additional electron shells or increasing energy levels, principal energy levels. So it's that simple. All right, and then going across, it's the same outer principal energy level. Use the word outer now, or valence electron shell. Use that one because it's the outer one. So they're all the same distance from the nucleus, but the protons are increasing. So the nuclear charge is increasing, and so they are getting drawn closer and closer to the nucleus. So they decrease across a period. So increase down a group, decrease across a period. They're the main points. Now, a question will probably not be worth 1 mark. It might be worth 2 or 3, and even if it is worth 1 mark, you may have to say quite a lot of different things. So we have to go into the deep dive now. Now, this is quite complex, and it needs to be even more complex like this. If you're talking about a particular element, you need to say, well, the 2s or the 2p or the 2ps or the 2bxy. You need to give the actual specific orbital you're talking about for the specific question. Okay, so on top of that, I'm not going to do that in this thing. I'm just going to do a deep dive on the general principles. So first of all, elements have additional electron shells or increased principal energy levels. We've talked about that already. Okay, so now we're talking about the nuclear charge. The nuclear charge is increasing, but it is not effective because, number one, there's increased nuclear shielding, so that's negating the effect. And number two, the distance is much greater, which is an exponentially more effective problem than just the size of the force, as we talked about before. Okay, so I've tried to write that clearly because distance is exponentially more significant than size with electrostatic forces. And so the valence shells are also repelled by the inner electrons as well. So I've sort of said three things there. Okay, so hence the valence electrons are less attracted to the nucleus. That's a key point on its own. And then you can't stop there. So they're further away from the nucleus. And then you can't stop there as well. So atomic radius increases. So there's kind of 3 points there, 3 points there, and maybe 1 point there. And then you could get marked for talking about the specifics, depending on what element it is. So you can see that is a bit of a deep dive. All right. So going on to the deep dive for the periodic trend. What have I mentioned already? Elements have increasing electrons in the same outer principal energy level or valence electron shell. Yeah, I said that already. And have the same electron shielding, so same electron configure, the same electron shielding. I should leave it at that. But the nuclear charge increases, so the valence electrons. This is key. A lot of people forget this bit. Nuclear charge increases, and they stop there. So what? How does that affect the radius? So the valence electrons are pulled closer to the nucleus, don't stop there, and then give the final answer. So the atomic radius decreases. Okay, so in the later trends, I may not go to this level. There is a decreasing in atomic radii, ionic radii based on these same principles. So really try and get a good grasp of each one as we go along because in some cases, I'll start summarizing and not repeating key principles from previous trends.